hope you're doing well. So today we're going to solve another coding interview problem. And the problem today is that we're supposed to find the longest palindromic substring. So this is also a famous interviewing problem. So it's actually good for you to make sure that you know what palindromes are and make sure that you know how to solve the palindrome problem before actually getting to come to this problem. Okay, so the question is we're supposed to, given a string S, we're supposed to find the longest palindromic substring in S. And we're told that we may assume that the maximum length of S is 1000. And an example here is that, let's say we're given this input. The output that our program should bring is BAB because BAB is a palindrome. Also, ABA is also another valid answer because you can write this the same way, both forwards and backwards. So here's another example, and it works the same way as this example up here, whereby our program will only bring out the longest palindromic substring, and in this case here, these two B's are the longest palindromic string that we can get from this string here. So there's many ways that someone can actually solve this problem, and the first solution that someone would think about is the brute force solution, whereby you can actually find all the substrings that we are given, and then we can check whether they're actually palindromes or not, and then after that we get to find the longest palindrome. So that is the brute force approach of this problem, and that is the first solution that we are going to check out and see how it works. So let's do the brute force solution. Okay, so the normal base case here, you could check if there's actually a string or not, and if there's no string, you just return that. And then we are going to form a variable for longest, which is going to track the palindrome that we are going to return. Okay, so what we are going to do is we're going to loop through the string. We're also going to loop through every other character in the string to get the substrings. Sorry. -1. So, and then what we are going to do here is we're going to do a check. So we're going to check whether the substring formed is actually equals to its reverse. We know that palindromes are the same when written both forwards and backwards, so this is what we are going to do. And we know that this is how you do a reversal using slicing. So if they're equals, and if the length of this string here is actually less than the length of the string, of the substring I mean, we're supposed to set that string. And then after going through the entire loop, when the loop breaks, what we do is we return longest, which will contain our palindromic substring. So this is a brute force way to approach this problem. So let's see if it actually works. We have an error. So in line 10, we have an error, yes. I know, I've seen where the error is. Okay, so our code actually works. So that is the simplest brute force way that you can approach this problem. Let's submit and see. Okay, so it's taking time, and that shows you that this is not an optimal solution for this problem. So it's actually only faster than 5% of the online submission. So that shows you that this brute force solution here is not the most optimal way that you can solve this problem. So we're going to try and solve this problem using a solution which is more optimum and a solution which is faster and better. Okay, so I'm going to get rid of this, and then we're going to have another solution. And how we are going to go about it is that we're going to build palindromes from the middle out. What I mean is that we're going to loop through the string, and treat each character as the middle of the palindrome. And then you're going to try and build the palindrome by comparing the characters on the left with the characters on the right. So when it comes to this solution, one thing that you need to remember to account for is in case the lengths of the string are odd or even. So you have to remember to always account for that. Okay, so let's go ahead and work on it. So we're going to create a loop. We're going to loop through the string. And then for the moment, you're going to have this pass because you want to create another helper function. So what the helper function is going to do is that it's going to take care of what we have talked about, the middle out approach. It's going to help build the palindromes for us from the string that we've been given. Okay, so we're going to have that. So what you're going to do is that we're going to have an iteration. And then we have to make sure that the left and the right strings are equal. We're going to decrement, and then we're going to increment the right one. So after that, we're going to return the valid string that has been formed. Yeah, so that is our helper function. What it does is that it's going to do an iteration on the string until we find a valid substring, which is a valid palindrome. Let's get back to this. So what we are going to do here is that we are going to account for the odd and even lengths of the string. So in case odd, what we are going to do is that we are going to create that. So and then if the length of the odd string is actually longer than the length of our string pointer here, what we are going to do is that if it's longer, we are going to set the longest to the string. So and then we are going to account for even. We're going to do the same thing. But here we're going to have a +1 to account for the even. Okay, and then if the length is actually longer as well, we're going to do the same thing whereby we're going to set the string to that. So our loop is going to be going through and doing that for us. After our code goes through, what we want it to do is I want it to return the substring. Okay, so we're going to return longest. And that is how you go about this problem. So let's see if it actually works. And yes, it actually works fine. So the time complexity here is O(n)², and that makes it way better than our previous solution. And that is why this is actually the best approach that you could use when it comes to coding interviews. And let's go ahead and submit and see. We can see that our code is actually faster than 84% of online submissions, which makes it actually way better. So thank you so much. And that is how you go about solving this Leetcode problem, and see you on the next problem. Thank you.